Welcome to this explainer. Look, if you're a developer, you already know the exact feeling. You plug a massive language model into an API, you wrap it up in a super sleek UI, and suddenly, you're looking at pure magic. It's totally intoxicating. But it also leads to a really common trap. And it's exactly why our central focus today is this. Your AI demo looks amazing, but I still wouldn't ship it. We're going to take a slightly playful but highly technical look at why we really need to stop coasting on the vibes of a mind-blowing prototype. Because today, we are answering one crucial question. Why can an AI system look practically perfect in a demo and still be nowhere near production ready? Let's get into it.
We've all seen it, right? The perfect demo. It's this beautiful honeymoon phase. According to the engineering literature, the base capabilities of foundation models are just so incredibly impressive right now, and the abstractions are so accessible that it literally might only take a weekend to build a demo that completely blows your team away. But here is the hard truth. A successful AI demo actually proves very little. Really, all it proves is that a concept is mathematically and functionally feasible under perfect, highly controlled conditions. It proves that the latest model is smart, out of the box, sure, but definitely not that your overall system architecture is robust enough for the real world.
So, let's really dive into this. Why shouldn't a polished interface, or even a single brilliant model response, be confused with actual production engineering? Well, as AI engineering documentation points out, a 30-second screen recording showing a feature working perfectly in a browser sandbox is, well, it's practically a magic trick. It absolutely does not prove architectural alignment, it doesn't prove long-term maintainability, and it certainly doesn't prove consistency. The real danger here is that a polished UI can completely deceive your stakeholders. Plausible but wrong failures are the true risk at scale. The output can look totally correct on the surface, while the reasoning beneath it is completely unmoored.
To understand why this happens, we have to look at what those demos are usually hiding. Demos are inherently sterile. They rely on clean data, ideal user inputs, totally known execution paths, working dependencies, and basically zero edge cases. But the second real users show up, that sterile environment just shatters. Production reality means dealing with noisy, missing data, unpredictable latency spikes, strict permissions, external tool failures, and just highly ambiguous requests. Real-world environments are chaotic, and they relentlessly expose the architectural weaknesses that your weekend hackathon completely glossed over. Part 1. The happy path. Let's look at a simple order refund.
To really illustrate this massive gap between a demo and reality, let's look at a super common use case. Imagine a customer service AI agent designed to process order refunds. Think about how seamlessly this plays out on the happy path. During your demo, the user follows the script perfectly. They type, "Refund order 12345. The agent easily identifies that known order ID, it triggers the refund API, gets a 200 OK status right back, and confirms success to the user. Boom. It looks intelligent. It looks flawless. And honestly, why shouldn't it? The data is pristine, the dependencies are perfectly responsive, and the user did exactly what you wanted them to do. But what happens when a real user arrives, completely ignores your carefully planned script, and simply types, "Refund the order from yesterday"? Now, this is completely normal human behavior, but for an AI system, this is a massive wrench thrown straight into the gears.
The crucial point here is exactly what happens the moment that happy path disappears. First off, we hit ambiguity. What if the user made 3 separate orders yesterday? The agent has to know how to actually pause and clarify with the user rather than just guessing. But second, let's say it does guess an order and hits the API, but we get a tool failure. The payment API times out. Now we are in the absolute most dangerous territory in software engineering, unknown state. Did that refund actually clear before the timeout, or did it fail? Because if the agent blindly implements a retry without checking the state, maybe because it lacks idempotency keys, it might just refund the customer twice. As engineering techs note, keeping things frictionless is nice and all, but an autonomous system executing unsafe retries without state awareness, that isn't just a bug, that is a catastrophic architectural weakness that will drain your company's bank account.
Which brings us right to this stark reality from AI engineering best practices. A good initial demo doesn't promise a good end product. It might take a weekend to build a demo, but months and even years to build a product. Happy path success is just an incredibly weak signal for a production release, because it completely ignores failure handling. And failure handling is where 90% of your actual engineering time is going to be spent.
Part 2. Surviving reality. We need to move way beyond just saying, hey, the model generated good text.
So how do we actually bridge this gap from a weekend hackathon to a truly resilient system? Well, we have to look at how AI applications fundamentally contrast with traditional microservices.
Microservices are typically stateless and deterministic, right? You put the exact same input in, you get the exact same output out. Every time. But AI applications are inherently non-deterministic and probabilistic. And because they are probabilistic, they can produce unreliable output, which is a core characteristic that software engineers normally try to avoid at absolutely all costs.
We really need to clearly understand this definition of unreliable output. There is a massive gulf between the system can succeed and the system behaves reliably across realistic conditions. In AI, success for one invocation does not guarantee success for the next. Performance can fluctuate wildly. Even subtle changes in prompts or minor model updates can lead to entirely different code paths and execution logic. For a traditional software engineer who's used to predictable logic gates and unit tests that just stay green, this probabilistic reality is an absolute nightmare to test, secure, and inevitably debug at 3 a.m.
And as you scale, this danger just compounds. When your system's output is plausible but wrong, your interface might still look fantastic, but your backend reasoning is completely broken. When an AI tool misunderstands user intent or system design, but the output still looks incredibly confident, that gives developers and product managers alike a really dangerous false sense of security.
And the cost of that false sense of security is, frankly, staggering. Industry data actually shows that 70 to 80% of AI projects never even reach production. And among the few that do, many just quietly fail within their first year. Why? Because teams vastly underestimate the sheer complexity of stateful interactions, unpredictable execution paths, and tool-mediated actions. They build so enthusiastically for that happy path, and then they get completely crushed by real-world edge cases like latency spikes, missing data, and uncertain state when they finally deploy.
Which leads us to part 3, proving the engineering and actually hardening that runtime environment. So, what should development teams actually be checking before they even think about releasing an AI system into the wild? It all comes down to adopting an engineering-first mindset, grounded in 4 critical pillars. First up, failure handling and graceful degradation. If a third-party tool breaks, your agent absolutely shouldn't crash or start hallucinating. It needs to fail safely, maybe by smoothly escalating the issue to a human operator. Second, observability and workflow tracing. You have to be able to reconstruct the end-to-end chain of agent decisions, knowing exactly what prompt led to what tool call using distributed tracing, because if you can't debug a silent failure, you can't ship it. Third, safe recovery mechanisms. You need strict circuit breakers and idempotency keys to prevent catastrophic stuff like infinite loops or double billing a customer. And finally, ownership and continuous evaluation loops. You need rigorous real-world testing frameworks that expose the agent to actual, messy user complexity, not just a bunch of sanitized benchmark datasets.
And that brings us right back to the core takeaway of our explainer today. A polished demo shows me how your AI succeeds. But production readiness, that shows me what happens when the happy path disappears. True engineering isn't defined by that one perfect run when absolutely everything goes right. It's defined by how a system absorbs, diagnoses, and safely recovers from the inherent chaos of the real world.
So I'll leave you with this final thought for your next project. When you build that mind-blowing prototype this weekend, absolutely enjoy the magic of it. Celebrate it. But on Monday morning, remember this: a demo proves feasibility. Production proves the engineering. Take a really hard look at your current AI project. If your users decide to go completely off script tomorrow, is your architecture actually ready to catch them? It's time to stop coasting on the vibes and start building for resilience. Thanks so much for joining me on this explainer, and happy building.